Hey, Sun here. I'm a privacy and security researcher, and you're watching The Privacy Guides. In today's episode, we're talking about sensitive computing and how to do stuff on computers, making sure that whatever was done does not persist on its memory. So as you know by now, I'm starting a new business called Superbacked, and that involves using computers to type in really sensitive secrets and essentially convert them to encrypted QR codes. Now, obviously, if this is something that you have, or if you're backing up something you have on your computer, such as your master password for the password manager, so anything you type on a specific computer, well, it's okay to back that up using Superbacked. But if you're backing up, say, your mnemonic that was generated on a hardware wallet, well, you should never, ever, 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 ever type that on a computer that is not considered air-gapped. And even more importantly, or at least as importantly, on a computer that could persist data on the hard drive. So a lot of things that happen on computers are cached to the hard drive for some reason or another. And as I've said many times on this channel, with flash storage, it's not possible to secure erase the whole data in most cases. There are exceptions. And in today's episode, I'm going to explain one of those on macOS in the context of M1 Max. But, the main idea, or what we should remember, is when using SSD hard drives, it's not like in the old days of spinning hard drives. One cannot secure erase a specific sector of the hard drive like we used to, because essentially flash storage is designed in a way where you cannot override a specific part of that drive many times. So in order to make sure, or else that part of it would die. So in order to mitigate this, the drive controller essentially will not overwrite a specific part of it by design. It's going to leave the data there and use another, part of the drive until all of the drive has been used, and then it's going to start overwriting again. And the thing is, it gets even more complicated. Part of the hard drive does not appear to the operating system. It's like a backup, because the controller knows that part of the drive will die, and it will then, in order to guarantee that 128 gigabyte capacity, it will pool in that buffer. So it's like, I don't know how to explain this better, but like backup space that is not revealed to the operating system. So when you try to secure erase it, what are you really erasing, or what are you overwriting? Well, it's not deterministic. Now, there are ways of achieving this that are better, and a really nice, elegant implementation is the one that Apple has chosen in the context of M1 Max. There's this really interesting paper, which I'll link down there in the description, that goes down the rabbit hole of all of the security measures that have been put into place in the context of macOS and M1 Max. It's really fascinating, but the one that I want to talk about today is FileVault. So you may have noticed when you click on the Apple and you go to System Preferences, and then if you go to, again, System Preferences, you can secure erase all content and settings. Now, is that good? Does that actually secure erase, meaning override all the data on the hard drive? Well, the answer is yes and no. So it does not override all the data on the drive with zeros, for instance. It does not even do it one time. Usually to secure erase a drive, in the old days, you had to do multi-pass. I think 7 passes was considered, super top secret. But in the context of macOS, it does not do that at all. And the reason why I know this is if you enable FileVault on a computer that you just purchased, it's enabled automatically, instantly. That's not how it used to be. In the old days of FileVault, when you would enable it, you would have a progress bar, and it would take from a little bit of time to a whole bunch of time, depending on the size of the hard drive and how much data is present on it. So how can that be? How can FileVault just be enabled automatically? And how come when I click Secure Erase All Content and Settings, within a few minutes, my computer has been wiped? And the good news is it actually does count as a wipe. It's actually as secure as replacing all the data by ones and zeros, so it's really fascinating. So the way this is achieved, and I prepared a few slides here. So regular flash memory, and that's the kind of stuff that you have in little memory cards like this, or most SSDs actually. The way it works is you have different regions of the drive. This is really like a simplified version of it. But here there's data. So let's imagine that's like 4 blocks of data. And if you go about erasing this information, so if you put them in the bin and you delete the bin, or if you try to secure erase those specific blocks, well, what will happen essentially is very, very high probability this data will still be there. So I put it there as grayed out. It means that the operating system no longer thinks it's there, but the data is actually there. And then if you write more data, that data will be appended, and it's not going to use those regions, because again, you cannot overwrite those regions an infinite amount of times. So to preserve data lifespan, it will not reuse them unless it absolutely has to. Now, if you compare this to the flash storage or flash memory, I should have said, that you have in M1 Max, you have something called effaceable storage. So that's a very specific part of the flash memory that is effaceable. And what that weird word means is that it is actually possible to address those specific blocks in the same kind of way that we used to in the old days. It's possible to secure erase those blocks. They're not intended for heavy use, which means you'll never reach kind of the lifespan of all of those blocks. And what that allows one to do, and that's done seamlessly in the context of macOS and M1, is that all of this data is then encrypted with a volume key, and that's small k. And in the effaceable memory, or storage, I should have said, is the effaceable encrypted volume key. That means that if someone was to exfiltrate the data of the effaceable storage, they would not be able to access K, and K is the encryption key used to encrypt all of the information on the drive. And that's enforced using something called a key hierarchy. So you may have noticed that when you change your password on macOS, or when you enable FileVault, nothing really changes. It's like instant. Now, how is that possible? Well, that's really possible thanks to that innovation of effaceable storage. What happens is K is a persistent volume key, meaning it never changes, because if you wanted to change that, you would have to re-encrypt all of the hard drive data, and that's what used to happen in the old days of FileVault. In the context of newer flash storage, it's possible essentially to encrypt that key with, say, the UID, which is a unique identifier fused to the secure enclave of Macs at the factory, and that's typically used to mitigate supply chain attacks and stuff like this. That UID is what is used to encrypt K when you get the computer. Now, once you have that computer, you want to make sure that you enable FileVault, hence add your user password and to the UID. So essentially those two secrets are now used to re-encrypt K, and all old versions of encrypted K are then wiped because it's effaceable storage, meaning the operating system, or anyways, I don't know which layer, maybe it's this controller, is capable of doing this. So it's capable of secure erasing all of it, making sure that now you do have a new version of it that's protected with new credentials. And that is really super interesting. So that's really how macOS and M1 Max allow users to secure erase computers within minutes. And that is a really, really useful feature. So in the context of Superbacked, now I'm starting this business called Superbacked. There's a link down there in the description, used to create really secure encrypted backups. Well, if you're going to be doing this for secrets that you don't want to type on your daily driver, well, you need to do it on another computer. Now, I'm pretty pumped to say that Superbacked will run as an app image on Tails, and that might be the topic of next episode. Tails does this in a different way. It just does not write data to the hard drive, which is even better. But say you don't know Linux, it's overwhelming, and you just want to do things in a really user-friendly way. Well, what you're going to be able to do is go to the Apple Store buy a MacBook Air M1, bring it home, download SuperBacked, verify the integrity of the build using cryptographic signatures. That's something you're going to be able to do using command line. Even noobs will be able to do this. It's going to be very easy. And then you can disable Wi-Fi, do this stuff, create the encrypted paper backups, and then use that really amazing feature to secure erase the whole Mac, after which you can repurpose the computer for yourself, or you can actually bring it back to the Apple Store and get a refund, which is mind-blowing. This is such a convenient feature. Son of the future here, I'm actually editing this and I just realized that there's one really important thing that I did not mention, and that is crypto shredding. So the way secure erasing the Mac works using that, system preferences thing is very simple. It just wipes everything in the effaceable memory, or storage, I should have said. And that means that everything is then encrypted with an AES 256-bit key that no longer exists on the drive, and that was derived from the UID on the secure enclave and from the user password and another little piece of thing that I'm not explaining because it gets kind of complicated. But if you wipe the effaceable storage, you essentially crypto shred all the data on the hard drive. And that's why you can secure erase a Mac instantly. So yeah, I hope that was insightful. It's really interesting how one can do computing in a way that is secure. And that effaceable storage really made it possible at a new level. So yeah, thanks to everyone, by the way, who liked or followed, I should have said, SuperBacked on Twitter, and also who starred the BlockCrypt repository on GitHub. That is super helpful. So thanks again. There'll be links down there in the description if you want to do so. And I'll see you in the next one. Bye.